Hi, everybody, and welcome to this webinar, How to Build a Regionally Distributed Serverless Architecture. This is Alex, and I'm a senior software engineer here at Cloud Academy. Feel free to reach out to me on Twitter. I am Alex_Casalboni, or on Slack channels whenever you need help. And today I'm really excited to have my friend Rupak from Serverless Inc. Are you with us, Rupak?
Yeah. Hi,
okay,
everyone.
Cool. Are you excited?
Yeah.
Okay, let's get started. So even though this is not like a how to get started serverless webinar, would you like to start by adding some context about what is serverless computing and why are we here today? Maybe for the listeners not too familiar with the term.
Sure. Yeah. The term serverless has been debated over time. And although not the best word to describe what it truly means, a clear definition has really emerged. It really means that those servers exist, the developers don't have to really think about them. Think about it like Wi-Fi. For the user, it's wireless, but the router has wires. From the end user, the experience is really wireless, right? Similarly, in case of serverless computing, servers exist at the cloud provider's end, but the developer doesn't really have to worry about it. And that's kind of the essence of it.
That's right. That's a disclaimer, we always have to take care of. Joking. So what are we talking about today in today's webinar? So what tools, what technology we are using? We are, of course, using the serverless framework, and we are going to build a multi-region serverless app on AWS. So we might discuss how a similar setup may work for other cloud providers. Today we'll be focusing on AWS, and we'll be using the serverless framework. We will go through each individual building block that AWS provides to build such an architecture. And again, it's not how to get started with serverless. We will share with you additional resources if you want to get started from scratch. Okay, this is supposed to be a webinar for users, people, or engineers that already have some sort of serverless setup, and you want to go to the next step and go multi-region or global. Okay.
Cool.
So what's the agenda? So we'll start by discussing why serverless is such a good fit for web APIs, meaning HTTP, GraphQL, whatever protocol you're using. Let's just say web APIs. And then we'll discuss why going multi-region makes sense. What are the main reasons and advantages? And then I'll show you a live demo of an application that we built together in the last couple of weeks. And I have a lot of gotchas and challenges that we faced to share with you today. And we will finish with a brief cost analysis so that you know when it actually makes sense to you as far as cost to go multi-region. Cool. So what do you think, Rupak? Why is serverless such a great use case? So why are web APIs such a great use case for serverless?
Yeah. AWS Lambda and API Gateway, along with other services like DynamoDB, GraphQL, have changed the way we've been writing web applications today, right? So these are some of the tenets of serverless API. Top of the list is zero administration. Of course, you don't have to worry about maintaining or patching servers. The cloud providers take care of it. So a huge amount of work that developers used to do is not on their plate anymore. Built-in elasticity, which is also like auto scaling. The API Gateway and other AWS services scale automatically based on load, which is a huge thing. We have spent so much hours and time and money just doing that. It's taken care of. The other awesome thing is event-driven architecture. The whole application development paradigm has shifted to events. A lot of AWS services trigger events, and your functions can subscribe to them and take action. So it's a new way of event-driven architecture has been around for a while, but Lambda and event-driven services have enhanced that experience.
That's true. So even if you have like synchronous APIs, you can still react to events like file
correct.
uploads and manage these things differently than we
Correct.
used to do in the past.
And last but not least, a huge thing I think is pay per execution. You only pay when your function gets called. So you never pay for idle. You can never over provision. It's always always based on how much you need. So that's awesome.
That's right. So let's see what it looks like on AWS. So this is the typical single region setup. For example, in US East 1. And in such a setup, very simple application, let's say one Lambda function and one DynamoDB table. You want to have an API gateway endpoint in front of your Lambda, so your users can invoke it through HTTP calls. And in the typical setup, you have an edge optimized API gateway endpoint. And in the diagram, it is actually out of the region because edge optimized endpoints are based on CloudFront distribution. So even though you have only one API gateway in your region, where you deploy the API, your users, so whether they are in the United States, in Europe, UK, or Japan, for example, they will all access the API through the same API endpoint that is globally available through Amazon CloudFront. And that's how API gateway edge optimized endpoints work. So this is the typical setup. Let's see what about costs. So this is an estimate with very, very low numbers, like 15 read and write capacity units for Dynamo and a couple of million requests per month for Lambda and API gateway. So 2 million requests per month is about 1 request per second. That's roughly the scale of such a small, simple application. And still, we get, and we're using like a 1 gig of RAM for Lambda, so not the cheapest. So we get to a total estimate of $20 to $25 per month. And as you can see, compute and database, in our case, Lambda and Dynamo, and app services, so API gateway, are pretty much balanced. If you use a cheaper, less powerful configuration for Lambda, this number will go really down almost to zero with this type of load. So this is a reference for later when we will compare costs to a multi-region architecture.
You can't really beat that price, can you? That cost is amazing.
Yeah, that's for 1 request per second. I'm not even considering free tier here, I think.
Right.
So that might be even cheaper for the first 12 months, I think. So just a quick note, I've mentioned edge optimized API endpoints. So they used to be the only option available until a few months ago, until November 2017. And again, they are based, under the hood, they were using a managed CloudFront distribution that allowed you to be global, to allow your users to access your API wherever they are in the world, thanks to CloudFront's network. So in a way, if we have a mono-region serverless application, you are already global. So today we're not discussing how to go global. We're discussing how to go multi-region. So if you remember the diagram, your users will all use the same endpoint, and CloudFront will take care of routing their request to the API in the region where you have deployed it. And since November 2017, you have a new option of regional API gateway endpoints. So we'll see what is the difference. For now, just remember, if you never heard of it, just remember it's a simple select box in your AWS console. So nothing really changes as far as how you configure the API resources and the Lambda code. There's no difference. We'll see what is the actual difference later on. So how hard is it to define a serverless API with the serverless framework? That looks pretty simple, right?
Right. Yeah. I mean, for those who are not familiar with the serverless framework and have not seen the YAML before, it's pretty intuitive. Here you can see a screenshot of a serverless YAML. You configure a provider. In this case, it's AWS. You give it a runtime, which is Node.js in this case, and then you define functions. It's pretty intuitive. You map a handler, which has your code for the function, and then you define events. And in this case, we see that we have an HTTP event with a path, and you can even define stuff like CORS, which is pretty hard to do in conventional methods. And you can see it's just a flag here, it's CORS true, and that's all it needs. So serverless framework kind of intuitively, in a very simplistic way, brings around the mappings, and it does all that automatically behind the scenes.
Right, that's pretty awesome. I remember when it came out a couple of years ago, and now it got even better. I love it. So this is, the typical mono-region setup, and from now on, let's start discussing why should you go multi-region, and what's the point? What are the pros and cons, and what does global mean in this multi-region mindset?
Yeah, so why should we go multi-region, right? To make our application resilient to outages in a region and achieve high availability. That's kind of where I'm coming from. Full region failures of a service are not very frequent, but they do happen. Multi-region redundancy can help us achieve high levels of we have been deploying AWS using, no, can you go back? Yeah, sorry. AWS has like over 15 plus regions worldwide, and more are being added. But we can utilize multiple regions and backed by regional API gateways to make our services redundant, and that's how we achieve high availability and reliability. Can go. Let's look at some of the tenets and how we can achieve cross-region failover. One is to do active-active setup, where you achieve, that means having 2 or more regions actively serving requests that will keep your application up if one region goes down. Same with the case of fallback. It will switch over in the case of failovers, large-scale failovers of a region. It can just fall back to the other region. This also improves, like using regional endpoints are generally slow than edge optimized endpoints, and we'll see in a bit. But if the client is closer to the region, the edge optimized endpoints can be slower than regional endpoints. And we will show a demo that kind of describes it with some metrics. And we'll use Route 53 for latency-based DNS record sets that can help us like automatically monitor health of our endpoints and automatically switch the DNS from one region to the other if one of the regions become unhealthy. So this all comes together.
Right, that's great. So we want to increase availability. We want to be able to fall back to the closest or the fastest or the one region that is not down in case of disasters, because those things happen. And sometimes we also want to discuss latency, right? So sure. I think the biggest problem when you go multi-region would be data persistency and data replication. That's probably that's a really tough problem. So on AWS, we can simplify this problem by using the recently announced DynamoDB global tables. If you don't know DynamoDB, it's just a NoSQL database with like single-digit latency. It's pretty awesome. And with the newly announced global tables, you can have this multi-region, multi-master setup, where AWS will handle all the data replication across regions for you. Of course, you can set up the data replication yourself if you want to handle DynamoDB streams, but global tables are pretty useful if you don't want to deal with that. That's not impossible if you have 2 regions. If you want to have 3 or 5, that's more or less a nightmare. And the interesting thing is that you can use global tables without rewriting your application, without changing your DynamoDB queries at all. Of course, there are like conflicts problem, cross-region replication problems that you have to be aware of in the way you write your queries, depending on your throughput. But that's, we could do another webinar about that. So let me show you what is the, how the architecture changes when you add one more region. So this is how you would do it on AWS. For example, I had already my US East 1 region, which is in North Virginia, right? And I have added EU Central 1, which is Frankfurt, Germany. A few differences. So our DynamoDB table are set up as a global table, so they are automatically replicated. We just mentioned that. And if you remember, API Gateway used to be out of the region because it was optimized, but now it's, in my diagram at least, it is inside the region because it is a regional endpoint. So there is no CloudFront distribution serving or routing your request to API Gateway, but your users from, depending on where they are, will hit the closest region. So for example, if a user is in the United States, it will use Route 53 as a DNS resolution service to find out which is the closest region, so which has the least latency at that time, and hit, in our case, US East 1. Our happy user in the UK will invoke the very same endpoint, but Route 53 will route that user to the closest region, which is Frankfurt, Germany, EU Central 1. So again, you will not go through Route 53. It's not a proxy. It's just your DNS, basically. So these two users are practically, in practice, just invoking the very same API endpoint. And I'll show you an example of that in a couple of slides. I'm not discussing pricing yet. We'll get to that at the end of the webinar. So let me show you a live demo. Let me show you a real application that we have built. First of all, let me tell you about the application that we have designed to be able to show you a very simple API design. So this is the GitHub repo, and the application that we have defined creates 2 API endpoints, one for GET and one for POST. So you can either read a given key or write a value for that key with a POST request. So it is a very simple API design. Of course, it's not a production-ready application. It's very simple just to demonstrate the concept. So what is the stack? So we are using the serverless framework. The new version just came out today, but this is also available and perfectly working with the previous 1.25 version. We have 2 Lambda functions, one for the GET and one for the POST endpoint, and we have 1 DynamoDB table. This stack will be deployed to 3 different AWS regions. In my setup, it'll be Frankfurt, Dublin, and Oregon. So 2 in Europe, 1 in the United States. And as I mentioned, we're going to use 1 single API endpoint for all of them. So here, this is the API endpoint that I'm going to use. Let me show you what it looks like. So I hope it's big enough. So I've hit this global.fast website subdomain with the /key. In my case, I'm using the hello key. As you can see, the value that I've stored previously is hello from Switzerland. And the value was written in Dublin, but now I'm reading it from Frankfurt. And that happens because I am in Switzerland right now. So Switzerland is much closer to Frankfurt. So this globally available latency-based endpoint routed me to the closest region, so EU Central 1, right? So let me show you a more intuitive UI to visualize this. So this is publicly available, same domain, but map subdomain. Let me show you the application. So this is the world, and these are all the available AWS regions, and this is me. I'm in Switzerland. If you open the app, you should see that you are, wherever you are. And if you click on the user, you'll see where you are. It will tell you what is the closest region. In my case, it's Frankfurt. As you can see, Frankfurt is like less than 300 miles. And here is the list of the closest regions to you. And the highlighted, the underlined region correspond to the colored region in the map. So the color regions are the ones that I have set up in my multi-region application. So I have Frankfurt, Dublin, and Oregon. They are colored, as you can see. So if I click on Frankfurt or Dublin, you see that a sidebar will appear, and you can read keys. So if I read the same key that I was reading previously, it'll be hello from Switzerland. So I'm reading from Dublin. The value was previously written from Dublin. But if I read the same value from Frankfurt, it will tell me that it was read from Frankfurt and written in Dublin. And the same happens if I read the same key in Oregon. So now I can try to change it, like hello again. I'm writing the value to Oregon, and now I can switch back to Germany and read it, and something changed because people are playing with it. So be polite if you're using my demo live, because this webinar is recorded.
That's
So
cool.
the value now is hello again, and you can see now we are using regional endpoints to read and write values. So I'm not using this global.fast website, because that will always route me to the closest region, which is Frankfurt. If I want to read or write from specific region here in my UI, I'm using regional endpoints directly. And you can see how the time changes. So it's like 100 milliseconds from Dublin. It's 120 from Frankfurt. It's a bit more, like 300 from Oregon. So this is not a crazy application, but it shows you as you start writing new values and putting new values into the application, how the data is replicated cross region. And since we are also writing which was the writing region into DynamoDB, when you read it from another region, you know where it was written from. So this is interesting, blah, blah, blah. So people are playing with it. Nice. Very simple app. The front end is public. You can find it on GitHub, and the backend is also public. So that can be your reference multi-region application if you want to build one. So let's go back. This was my very simple demo. Let's get a bit more technical and see what's going on under the hood, and some of the challenges that we have encountered while building this app. So, Rupa,
yeah,
what do you think?
Alex, a quick thing before you move on.
Sure.
Yeah, it was pretty cool, man. Pretty cool UI. Quick shout out to Alex Debris from Serverless Inc., who also helped us work on the backend. So thank you, Alex.
That was great.
Yeah. Okay.
Here's the repo. Here's the repo from Alex Debris. So this should be your reference if you want to start a brand new serverless application. There are step-by-step instructions on how to set up the custom domains, how to set up certificates, how to set up Route 53 latency-based routing. It is a very nice reference. So check it out. Thank you, Alex. Okay, let's go on. Gotchas. Right. What about the serverless framework? There are a lot of things.
Yeah, there are a lot of things involved in the app, and you can see if you look at the code, but there are a couple of things that are not purely done through a CloudFormation. So we used two serverless framework plugins, serverless domain manager, and the serverless Dynamo auto scaling. The domain manager plugin basically manages custom domains with the API gateway. And in our case, if you look at the code, you'll see there's one attribute called endpoint type that is set to regional. By default, it's edge. So we will set it to regional for our use case. For DynamoDB auto scaling, I think since June 2017, Amazon enabled auto scaling for DynamoDB tables, and this plugin kind of helps configure and enable auto scaling for Amazon DynamoDB. So great plugins, and these plugins actually hide a lot of complexity. Some are manual steps, and Alex will talk about certificates and stuff, and then a lot of custom domain configurations, building multiple global table, setting latency records in Route 53. Those are all done via these plugins, and they kind of hide that complexity inside of it. But you can look at the plugin code or our code to see how it is done.
So I suggest doing it manually so that you can enjoy the pleasure of using these plugins.
There you go. Yeah.
Okay, great. So I want to tell you a little bit about the details. So for example, the first building block that we used was ACM, Amazon Certificate Manager. It's a great service to manage and automatically renew your secure certificates. And so in our case, it is used to basically map your API gateway custom domains to a certificate, because when API gateway will respond to your requests, it must make sure that the client knows it has the right permission to be the server for that domain or subdomain. Otherwise, your browser will get a really bad security alarm. So how do you use it? Well, you just request a certificate in every region that you want to deploy your multi-region application. And then the domain manager plugin will help you with mapping this certificate to your custom domain in API gateway. Of course, the service will take care of automatically renewing the certificate, year by year. So it is a semi-automatic process because there is an email verification. If you own the domain, that's really a one-click operation. So it requires some human intervention, but it is a great service. So
hey,
the
Alex,
next, yeah, sure.
How much are you charged for the SSL certificates?
Good news, it's free. So
wow.
this is even more awesome.
Yeah.
So it's totally free. As long as you own the domain, you can even buy domains on AWS. But in my case, I already had the domain, and I imported the domain on Route 53 to handle DNS. And then you can create as many certificates as you want, totally for free.
Cool.
That is a pretty cool service.
Yeah.
So the second building block that we need for this setup is Route 53. So we want to set up a latency-based routing, as we mentioned, and to achieve that, you need one CNAME record for each of the regions that you want to add to your setup. You want to have a latency routing policy. So when you create this CNAME record, you select the region corresponding to the API gateway regional endpoint, and then you select the latency routing policy. So we are using, again, the domain manager plugin that will help you creating this kind of records. And check my screenshot here. This is my current configuration. So I have one, since I'm using subdomains, I have one record for my CloudFront distribution hosting the static website for the map, and I have one CNAME record for each region. And remember, here the value is the regional endpoint, your API gateway regional endpoint. This is interesting because you can still use the regional endpoint to force and read or write from that specific region. But if you want to have one single endpoint, in my case, global.fast.website, this is the setup. Pretty cool. Another interesting feature is that you can set up health checks. So optionally, you can have specific API endpoints in your API gateway definition that will act as health checks for Route 53. So you set up, I don't know, like a / health check, and those specific spatial endpoints will make sure that all the components of your application are up and running. So if we have Dynamo or if we have a third-party service, you can create this kind of endpoint to check that everything is okay, and so that when Route 53 detects that something is wrong with that region, it will automatically route all the requests for that domain to another region. So this is really the point of why we're doing this. We want to be tolerant to regional failure.
This is the fallback we talked about earlier, right?
Exactly. So since the routing is done at the DNS level, Route 53 will help us route you to the closest region with the latency policy and fall back to another region in case anything goes wrong. And This happens anyway, but with health checks, you can make it even better and have a specific check on the services that you need. Maybe not just a simple GET API, but something more complicated to check every service and every third-party service as well. Okay, so quick note about regional versus edge-optimized endpoints. So we already mentioned that regional endpoints do not use CloudFront. So there is no CDN. So basically, based on how far the client is from the closest region, regional endpoints might have, a different latency with respect to the edge-optimized endpoint. Let's say that on average, regional endpoints are a bit slower unless you are really close to that region. And that happens because you're not using CloudFront's CDN, CloudFront's network. I have some data, some statistics to show you, but this is the point where I figured, what if I put a CloudFront distribution in front of my latency-based routing endpoint? So that's an option. Good news is that it will speed up actually all the responses as long as you are okay with caching. The bad news is that it wouldn't really work with the same custom domain. So you will need to use another one because of the certificates and on how DNS work. So I have prepared some statistics to show you. So let's check the numbers first. So the fastest setup that I have here is like around 40 milliseconds. So all these experiments are using the same region. It was Frankfurt, and I was here in Switzerland. So the fastest one is around 40 milliseconds, and then 60, and then 80. So the first one is a CloudFront cache hit. So this is like cheating. This is I'm not hitting the regional endpoint at all. I'm not hitting anything. I'm just getting the cache hit from the closest edge location from CloudFront. So this is the fastest thing you can get. And the second one is an edge optimized API gateway endpoint. So this refers to the typical single region setup where you have API gateway and CloudFront optimizing the global latency for you. So this is more or less halfway between a cache hit and the regional API gateway endpoint. So here I am hitting the latency-based routing endpoint, and I was hitting directly the Frankfurt regional endpoint. This is more or less twice as, the latency is twice as much, and it is slightly slower than the edge-optimized API. Of course, this really depends on how close or how far you are from the edge location and from the region that you are reading or writing from. This is the data I got. And the last value, which is really much, in another order of magnitude, is a CloudFront cache miss. So I mentioned that the good news is that with CloudFront in front of your regional API gateway endpoint, you will actually speed up with cache, because that's what cache is for, but in case of a cache miss, it will be really, really slower, up to 5 to 10 times slower with respect to a cache hit. And there is no real official statement about this. My current theory / assumption / thinking is that this is based on how CloudFront manages like DNS and SSL handshakes. So they're not really reused or cached, so that if you have a cache hit, it's great. If you don't, you are actually adding more latency because CloudFront will need to talk to your regional endpoint, and that's not really as fast as going straight to the regional endpoint yourself. So these are empirical data. I'm not saying it's the same everywhere in the world or with every region, but this is what I found. I'll be happy to get deeper and maybe share more results with other interested developers. So last component. The last component that we used is DynamoDB global tables. So I have a few gotchas for you here. The first one is that not every AWS region is supported yet. You only have 5 regions. So I have used 3 in my setup. I couldn't use 10 or 12 because only 5 are supported. If I remember correctly, it's like 3 in the US and 2 in Europe. Another gotcha is that in order to add a new region to your global table, all the tables must be empty. So this doesn't really make it easy to add new global tables to existing applications. For example, if you already have a serverless app that's using DynamoDB and you want to make it a global table, you really can't, at least not automatically, unless the table is empty. So there are workarounds about this. The community is talking. How do you do that? I would expect this to be solved, this problem to be solved once the newly announced point-in-time restore becomes globally available later this year. So it's been announced, I guess, when you are able to restore a DynamoDB backup into a global table, that would be much easier, but that's my assumption. Let's see what happens. For now, this is great for a new app, and you need to know how many regions you want or you need in advance. So it's a good thing to know. And the third gotcha for you is that auto-scaling matters here. Don't forget auto-scaling. And this is important because basically, in a few words, your write capacity is shared across regions. So let me show it with an example. Let's imagine that in our single region setup, we had like 15 read capacity units and 10 write capacity units. So in the ideal world, we will be able to evenly split our read capacity units to our 3 regions, assuming that your users, your requests are also evenly distributed. But that's a big assumption. But let's say in general, you will be able to distribute that and to split the capacity, read capacity units. But you cannot do the same with write, because every time you write to one of those global tables, that write will generate one write in all the other tables as well. So that's why write capacity is shared globally. So you need to plan for that. So imagine we had like 15 read and 10 write. So we can split the 15 across our 3 regions, but we cannot split the 10. We still need 10 everywhere. And auto scaling is important because, of course, you can be elastic and you can react region by region differently based on the load that you have in that region. So this is pretty powerful if you do it right.
Quick note, Alex.
Yeah.
Quick note for everyone. You can manage these read and write capacities using the Serverless DynamoDB auto-scaling plugin, and all is done declaratively in the serverless.yaml under the capacities.
Exactly, that's super simple. I did it in like 5 minutes and it worked. So it's amazing. So the suggestion officially is to have the same basic configuration for every region, so you don't have to manage that manually, and then configure auto scaling which is like five, maybe five configuration lines in your serverless YAML. Super easy. Okay, so let's get into the
Hey, Alex.
the geek part. Yeah.
Yeah, I know. I had one more question on global tables. So, how do I add global tables to my existing DynamoDB setup?
So that's kind of a problem right now. There are workarounds that allows you to transform your current DynamoDB table to a global table, but you cannot just add a global table to your existing ones. A workaround could be that you do like a blue-green switch. So you create a totally new global table with the regions you need, and then you start writing data into it. Maybe you set up streams into your old DynamoDB table to write into any of the regions in the global table. And then at some point, you just switch to this new table, and you also have historical data. I would expect this to be much easier in the short term, in the near future, with the point-in-time restore capability that's not available yet. But yeah, today it's kind of a pain.
It's still very useful though. Yeah.
Yeah, it is. So I don't know if I would do it for a huge table, but if you just started a few months ago and you want to go global, it's still an option. Cool. Let's go on. So this is the last section of the webinar, and I want to tell you a little bit about costs, because it's not very intuitive. So far, you may have thought that going multi-region is always more expensive, but is it? Let's see. So this is the mono-region, single region cost that we had a few slides back, and this is the multi-region cost. Here I'm assuming 2 regions, not 3, not like my demo. Let's say 2, just for simplicity. As you can see, the cost for Lambda and for API Gateway will be more or less the same, because they are elastic, you don't pay for idle, and you don't have hourly costs. So as long as your traffic is evenly split, or even in a weighted way, but as long as you split the traffic across regions, the cost for Lambda and API Gateway will not change much. The real change is for DynamoDB, because as we saw, you cannot just split read and write capacity across region and that's it. You have this shared write capacity, and so what's the overall analysis for, compared to a mono region? This 2 region architecture will cost you more or less plus 30%, and that's because I had like 15 read capacity units and 10 write capacity units. That really depends on your application. Again, the cost for Lambda and API Gateway are very similar, and the cost for Dynamo almost doubled. So this is, this got my attention, and I was like, I need to get deeper. So my question was, but is DynamoDB going to be always more expensive? So I figured, what's the best way to tell people how to find out? So I wrote a function. So this is a function that will tell you if the DynamoDB multi-region setup is cheaper or not. So you pass number of regions, number of read and write capacity. It will compute mono and multi-region costs, and just return a Boolean. Super easy. So I said, awesome, I found a way to figure it out. But it is not really enough to, I thought there should be a way to visualize this and to more or less know when it makes sense or not without running code, right? So I'm kind of a math geek person. So I started plotting graphs and writing formulas. So this is the graph, the plot for 2 regions, and let me show you. So on the y-axis here, you have the percentage of cost increase. So if it's 100, it's 100% cost increase, means it costs you twice as much. If it's 0, it costs you the same. So for r equal to, as you can see, the curve will go down to 0 at some point. So what is on the x-axis? So here we have a ratio between read and write capacity units. So let's make an example. If you have as many reads as writes, so you are at 1, and with 2 regions, you will pay more or less 80% more. So that's a lot. If you have more writes than reads, you go up to 100. But what happens if you have, I don't know, 10 times more reads than writes? So you are here at 10, and it will cost you the same. If you go above that, if you have really like 20 or 30 times more read capacity units than write capacity units, it will be even cheaper. So this got me a bit excited. So I thought I need a way to plot this for different values of R for 3, 4, 5, 10 regions. What changes? So I woke up on Sunday. I got a piece of paper, and I started finding this formula. So here, X is again the ratio between read and writes, and R is the number of regions. And this is the formula. If you don't believe me, I have proof. So this is my piece of paper. This is how I derived the formula. If you want to know more. And the cool thing of this is that this holds for every region, because this only depends on the ratio between the cost of reads and the cost of writes. So even if that changes across regions, the ratio between reads and writes is always the same. So this formula is valid for every region, no matter the cost. Little asterisk, it's not considering storage. That will be just a constant to add, because you will have to have this constant multiplied by the region. So, but in most cases, the storage is the small number in your cost formula. So let me show you a graph for different values of R. So with 2 regions, we had this blue. With 3 regions, we had this orange, and with 5 regions, which is the maximum you can go with DynamoDB global tables as of today, you have this green line curve, actually. As you can see, they all go to 0. So if you have, for example, 30 times more reads than writes in your application, no matter how many regions you have, it will always be cheaper to go multi-region than to stay mono-region. This is pretty interesting. So of course, this is a simplified model. It doesn't take auto-scaling and the DynamoDB storage costs into consideration. But I think if you visualize this, it's a powerful tool to understand, when going multi-region is cost-effective. Since what you gain is not just latency, you actually get failover across regions. So you might actually be willing to pay, I don't know, 60 or 100% more to gain that level of high availability. So I'm not saying it only makes sense if it's same cost or cheaper, but consider, even if you were not giving high priority to your availability in your application so far, just remember that going multi-region might actually be cheaper than staying mono-region. I was not expecting this when I started my analysis. So I'll be happy to share more if you guys have questions at the end of the webinar. And actually, that's it. So this is everything I had to share. Now I'll be super happy to review some of the questions that you guys have been asking so far. We have quite a lot of questions. So could you give an overview about plugins installation? So sure, let me go back to the slide where I'm linking. So if you check this repo here, so it's Alex Debris from Serverless Inc., and it's Serverless multi-region. Let me show it to you. So this is the backend repo for the application we have built. And if you check serverless.yaml, this is the plugin that we are plugins that we are using. So serverless domain and serverless DynamoDB autoscaling. All you need to do is add this both to your serverless YAML and to your package.json. As you can see, they are dependency in our repo. So when you do npm install, you will install all the dev dependencies and the plugins will be installed for you by npm. So this is all documented in the repo README. So just follow step by step and you'll be able to build your own serverless application.
I just wanted to quickly add that it can be even easier than that. You can just say serverless plugin install -n and give the name of the plugin, and it will install it for you, and it will add those lines that Alex just showed into your serverless.yaml. It's just as simple as
right. That's a good point. Yeah. So yeah, I did it the old way.
Yeah, I know.
Now you have a new command for that.
Yeah, sure.
So let me go back. So another question is, how can DynamoDB be cheaper if we are always having to provision more write capacity? So let me go through that real quick. So the point is, if you check the formula, I actually have the function. Okay, if you check this function in the multi-region cost estimation, we are dividing the read capacity unit by the number of regions and multiplying the write capacity unit by the regions. That means that even though write capacity is shared, so you need to multiply that by the number of regions. So you always have more, you have to provision more write capacity. You can assume that your read capacity will be split across your regions. So for very high value of read capacity with respect to write, your cost will go down. And this is not cost in dollars. This is an increase, a percentage increase. It means that when it's 0, it will cost you the same, right? So at some point, when you have a lot of reads with respect to writes, it will actually start getting cheaper because you can split that read capacity across regions, even though you have like n times more write capacity to provision. I hope that makes sense. If it doesn't, just reach out to me on Twitter. I can share more like geek formulas with you. So question, in multi-region, if one region is being hammered with requests and another region is mostly idle, will Route 53, sorry, I've lost it. Will Route 53 switch the request to the idle server? So this is not a load balancer. So what you are describing is more similar to a load balancer. No, unless your region, unless the closest region is so busy and so overloaded that it starts being slower than the than other regions in your setup. So that is possible, but it's not. So Route 53 is not checking your like Lambda scalability or your number of requests coming. It's not a load balancer. It will work at the DNS level, meaning that by default, it will just give you the DNS resolution to the closest region with respect to where you are right now. So in the general case, no. If you set up latency routing and health checks, it might happen that a health check fails because the region is really overloaded, and then yes, you might be routed to another region. And that is the failover that we want to achieve to serve our users the best. So that is correct, but not in the load balancer sense of how it works. So with another question. So with this global approach, who will be responsible for protecting data? So it is still on you. It's not that. So everything that DynamoDB Global Tables does for you is helping you replicate data across the regions that you have configured it's not taking care of data protection in any way with respect to a monoregion. So nothing changes if you're using Dynamo. That doesn't really change with going multi-region or not. Okay, another interesting question. Do you think that Amazon Aurora Serverless will ease the use of SQL databases in regionally distributed application? Yes, so I didn't touch on that. I didn't mention that. We have chosen DynamoDB Global Tables because it is available to everybody today. It was announced a couple of months ago. But yes, I think that when Aurora Serverless, multi-region, and multi-master is available, hopefully in a few months, I don't know when, but hopefully this year, this might be, I wouldn't say a preferred option, but if you like SQL, if you have a relational model and you don't care about like single digit latency that Dynamo provides you, you want to use like a MySQL or a Postgre database, Aurora Serverless would be a great option for multi-region setups. So definitely. I haven't had the possibility to try it. I don't know many people that did, to be honest. If you did and you think it's not a good option, let me know. I think it is. So let's see if we have another question or two. We don't have a lot of time left. Hi, Alex. I'm building a blogging website. I don't want to use DynamoDB. Instead, I intend to store data on S3. Is it a feasible option? Well, as long as you can replicate your S3 data across regions, that is a viable option as well. So I showcased how to do it with Dynamo because it's more useful in the general sense for a general purpose application. But definitely, so you could set up your S3 cross-regional replication. I cannot remember if it's available by default with a couple of clicks like for Dynamo. But that's definitely an alternative. If you don't need Dynamo, if you don't need Aurora Serverless, you could use S3. That's as durable and globally available as these other options. Maybe let's take the last question. So how would you go about making the front end global like now? Okay, now let me read again. How would you go about making the front end global? Yes, your assumption is right. Right now, it is a single S3 bucket, and I am serving the static website through CloudFront. So if you noticed in my Route 53 screenshot here, I have a record in Route 53 for the map subdomain, and it is just not an alias for my CloudFront distribution. So yes, I'm just serving a static website through CloudFront, and it is stored into S3. So this is totally serverless. There is no EC2. I really don't want to host a static site on a server. I mean, I don't want to pay by the hour for it, at least. If you're curious about the front end, it is just a simple React application that I've built and uploaded to S3. Really simple. You can build it yourself if you clone the repo. I think we are out of time. We still have a few questions that we didn't answer, but if you have more interesting question, feel free to tweet at me. I am Alex_Casalboni on Twitter. So I'll be happy to answer.
I'm Rupak G at Twitter.
Yeah, that's great. Thank you, Rupak. I forgot. So I hope you guys enjoyed the webinar and learned something new. If you have doubts, questions, just reach out to us on Twitter, and we're going to share the questions that we did not answer and more technical details about the setup in an upcoming blog post. So don't worry if we didn't answer to your question. We're going to publish a lot of the material that I've shown today. If you want to have all the links, here is the link to download my deck. It's publicly available. You can find all the links to the repo and to the sample application in this deck. Okay, I hope you enjoyed it, and thank you so much, Rupert.
Thank you. It was great.
Bye, everybody. Have a good day.